All right, folks. Gonna do this because hopefully this will help you out when you guys try and do some of this stuff tomorrow on your own. So let's try and have at it. Chapter 4, Section 5 is really the reversal of the chain rule, which was our idea of a composite function, a function within another function. And so in this scenario, we can go ahead and we could make this a longer process by you know, multiplying this out and then distributing the x plus 1 and then coming up with the power rule, but that just kind of seems like tedious work. So instead of that, we're going to go ahead and use something called U substitution, where we try and come up with the innermost function. So before we start this problem, let's think about what the chain rule was. Let's say, we had some function, y equals, hold on one second here. Y equals, x cubed plus 2x all raised to the fourth power. So if I said, hey, let's find the derivative of that, well, we'd do the derivative of the outside, leave the inside alone, and then multiply by the derivative of the inside. So this would be 4 to the third, leave the inside alone, and then multiply by the derivative of the inside. Well, what we're going to do now is we're going to look at this scenario and try and revert back to our original function. So the commonality between these two is this innermost function. That's the same no matter if it's the original function or the derivative. So the first thing we want to do is be able to identify that. And that's what we're going to let be represented by u. Okay? So hopefully this will help with that. Okay, so when we look at our integrand here, we're going to say, okay, what could we let represent a u? Well, if we let this innermost part be u, okay, then we're going to say, okay, let's let u equal x squared plus 2x minus 3. So far we're going to have this integral up here be equivalent to u squared, because that's what u is right here, okay? However, we still have this x plus 1 dx. So right now, we don't want to be able to have some u's and x's, because this right here tells me, hey, everything needs to be in terms of x. Well, if I have a u squared here, I better have a du at some point. So I got to be able to interpret this du. Well, that's how we're going to take the derivative of this to be able to get a du. So when we differentiate here, we're going to get du dx, if we were to take the derivative of both sides, equals 2x plus 2. Well, you might say, well, I got a du and a dx. Well, if we go back to 3.9 in differentials, part of that was, let's say we're magicians and we can get this dx to be on both sides. So let's say I multiply both sides by dx, if we could. It really is just a formality because this means the derivative of u with respect to x. So what I want to do is, instead of writing du dx on this side, we're just going to write du equals whatever the derivative is with dx on the right-hand side. So right now, wherever you see something like this, we could replace it with a u term. Well, this is close to x plus 1. What could I do to both sides to get rid of the x plus 1 dx and get it into terms of u? Well, what if we multiply both sides by 1/2? So right now we have 1/2 du equals x plus 1 dx. Well, isn't that what I want to get rid of right here? Yeah. So I'm going to replace the x plus 1 dx with 1/2 du. I've already attempted to say, like, hey, we need to have this in terms of u, but I'm going to throw a 1/2 out in front. So using this process, I can go ahead and manipulate this to look a little bit more comfortable with what we're dealing with here. So if I know this is equivalent to that by using this u substitution, let's just go ahead and take the antiderivative of this. So this is going to be 1/2 times u cubed over 3 plus c, which is the same as 1/6 u cubed plus c. However, we don't want our final solution here to be in terms of u. we want to bring what we had u equal and plug that back in here. So my final answer here is going to be 1/6 x squared plus 2x minus 3 cubed plus c. This is the antiderivative of this. Let's try another one. We look at 18x cosine of 3x squared dx. Now we got to ask ourselves, what would we let u equal? Well, part of the process, some of you might work with it and you might say, okay, we need to do process of elimination. Okay, that's fine. You can try different scenarios like letting u equal 18x or cosine or whatever it may be, but this function right here is inside another function. So I'm going to let u equal 3x squared. The derivative of 3x squared, we're just going to write du equals 6x dx. So if I want to rewrite this inequality or this integral, I'm going to say that this equals, not this stuff, this is just kind of our sidebar notes. So I'll do a better job of keeping it off to the side for the next one. We want to replace all of this information with our u information. So I'm letting 3x squared be u. So this is going to be cosine of u. And I have 18x dx that I still need to replace. Well, right now I have du equals 6x dx, which is close. If I were to multiply both sides by 3, then this side right here will end up being 18x dx, which is what I want to replace up there. So what I'm going to do now is I'm going to write 3 and du here because 3 du replaces the 18x dx. So this is an integral that I'm more comfortable with interpreting. And so now I just ask myself, well, what's the antiderivative of cosine of u? Sine. So this is going to be 3 sine u plus c. But just like the last example, we don't want u to be left in our equation. So we're going to plug in what u was in terms of, which was the 3x squared. So this is going to be 3 sine of 3x squared plus c. And that is my final antiderivative. Let's try another one. Again, when we look back at derivatives, part of the process was anytime we had a radical, let's go ahead and rewrite it. So that's what I'm going to do first. I'm going to rewrite this so I have a fractional exponent. So this is going to be 4x minus 1 raised to the 1/2 dx. This helps us to identify what the innermost function is. And in this case, we're going to let u equal the 4x minus 1. We let u equal the 4x minus 1. That means my derivative is equal to 4 dx. But if you notice, if we try and replace this integral is now going to be, well, if u is 4x minus 1, I can rewrite this as u to the 1/2. But I only want to replace dx, and here I have 4 dx. So how can I get rid of that 4? How about I multiply by the reciprocal, 1/4. So now those are going to wipe out, and I'm going to be left with the 1/4 du equals dx. So wherever I see that dx, I'm going to replace it with 1/4 du. I kind of do something when I replace it. I don't write it as times 1/4 du. This is going to be a scalar, so I'm going to pull it out in front of the integral and just write it like this. So this can be rewritten after u substitution as 1/4 u to the 1/2 du. So now I go ahead and say, all right, let's take the antiderivative. Add 1, divide by the new. So this is going to be 1/4 times. Well, that's going to be 3/2, but dividing by it will be 2/3, multiplying by the reciprocal, and then plus c. So as we go ahead and simplify this, this is going to be 2, this is going to be 1, so this will be 1/6. And we want to replace our u with what we had up here, 4x minus 1. So this is going to be 4x minus 1 raised to the 3/2 plus c. And that will be my final indefinite integral representation, or the result of simplifying that indefinite integral. Okay? So at the end of the day, what we're trying to do when we're looking at indefinite integrals using u substitution, you're given an integral that was the result of a chain rule. So in reality, we have to find the innermost function. Once we do that, we're going to let u equal that innermost function, and then we're going to let du equal the derivative of that, so that we have the integral of f of u du, and then all we have to do is interpret the antiderivative of f of u. Okay? And that'll be this big F means the antiderivative of little f. And once we get there, we don't leave things in terms of u. We go back to whatever our u equals equation was and plug that back in. Okay? Hopefully that helps. Some hints to help you identify like what the u is versus what du is. If you notice in this example right here, we let u equal the 3x squared. This degree is 2, which would mean my derivative's degree is going to be 1 less. So that'll take care of the x that's out there. So that might help in some scenarios. Is the higher degree will sometimes be the u, and then that'll help take care of any lesser degree. Just know that in these scenarios, du will never be in one, denominator, 2, exponent, 3, it'll never be in a radical, or in a grouping symbol with high exponent. Okay, so just know that du will never be in any of these scenarios, so that also might help you with identifying what your innermost function is. All right, best luck, and hopefully we'll see you later on.